So question 7, refer to figure 1.5. We have 2-point charge. Q1 is positive 0.3 coulomb and Q2 is negative 0.4 coulombs. They are separate by a distance of 6 cm as shown in figure 1.5. Calculate the resultant electric field strength at point A if the point is at a midpoint between the two charges. So class, if point A is midpoint between the two charges, so we want to find what is the electric field strength at point A. So electric field strength at point A will be due to the charge Q1 and also Q2. Okay, so at the surrounding of point A, we have 2-point charge Q1 and Q2. So Q1 will create electric field strength at point A. At the same time, Q2 also will create electric field at point A. So the resultant of electric field strength at point A will be due to the both charges. So, in order to find the resultant of electric field strength, we have to draw the vector for the electric field first. Okay, kita kena lukis vector dia dulu. So, if we refer or we recall the video concept that we discussed before this, in order to draw the electric field vectors, we have to use the concept electric field vector will be outward from charge positive and inward for charge negative. So Q1 is charge positive, so the electric field line will be outward from Q1. So it will be outward from Q1. So the electric field line is outward from Q1. So it will pass through point A, then pointing to the right. So this one will be E1. Okay, E1. At the same time, Q2 also create electric field. So the vector electric field E due to the Q2. So since Q2 is negative, so the electric field must be inward. So electric field untuk Q2 mesti masuk dalam charge. Kenapa masuk dalam charge? Sebab charge Q2 adalah negative. So from point A, so the electric field line will inward, masuk ke dalam Q2. So this one will be E2. Okay, so this will be the electric field created by Q2. So after we draw the electric field vector, we can see obviously the electric field at point A is E1 and E2. So bear in mind, electric field is a vector quantities. So we have to add by considering direction. So E at point A will be E1 plus E2. Why we plus? Because both are point on the same directions. E1 and E2 both point in the same direction towards right, menghala ke arah kanan. So we add up both vector. So how we calculate the magnitude for E1? So we apply the equation E is KQ over R squared. So E1 will be Q1. Then the distance will be the distance of point A to the charge 1. Plus with E2 will be K Q2 over R squared. The R here will be the distance between point A and also the charge Q2. So I label it as R2. Okay. Then we can put in the value. K is the Coulomb constant. So we have 9 to the power of 9. Q1 is 0.3 divided by the distance of point A to the Q1 will be 3 centimeters lah. Why 3 centimeters? Because point A is the midpoint between the two charges. So we have 0.03, 3 centimeter change to meter, okay? All calculation in SI unit. Then K9 to the power of 9. Q2 is 0.4 coulomb. But bear in mind, we didn't put in the negative sign, left out the negative sign, we just put in the magnitude of the charge. So the magnitude of the charge is 0.4 over R will be 0.03 squared. Okay, so when you solve it with calculator, you might pause the video to calculate the value. So you will get the resultant electric field strength at point A will be 7 to the power of 12 Newton Coulomb minus 1. Okay, the directions. So the direction will be to the right. Very obvious daripada vektor yang you lukis So resultantnya memang hala ke sebelah kanan, okay? So the direction is to the right. So this one will be our answer lah.